These are the notes for lesson 1.3, finding limits from a table. So what we're given is a blank table, and we have to use it to determine these following limits and a function value without knowing anything else about the function. All we know is that it's called f of x. We don't know what its graph looks like yet. We don't have an equation to plug in values, so we just have to use a table. The first limit they want us to figure out is as x approaches 3 from the left. So think about if you had a number line here, 3's in the middle. What is to the left of 3? Well, that would be 1 smaller than 3 or 2. We don't really have to do 2. I mean, you can, but we really want to get really close to 3. Let's be a tenth away, so 2.9. That gets us more precise. We want to keep going and just keep adding 9s and trying it. So now it'll start kind of not leveling out, but it'll start to get more clear what we should round to when you do lots of them. So it started out as 5.23, 5.25, 5.25, 5.25. So you can kind of see the pattern. It's going to get more and more to where these are just turning into 9, so it's 5.25 for this one. Now I'm going to clear that out so that I can do the next limit. So now I want to find 3 from the right. So again, picture the number 3. What's a tenth to the right of 3? Well, we want to be a tenth bigger, so that would be 3.1. And we get that. Well, then we want to get closer and closer. We don't want to keep adding 1s. We actually want to have 3.01. So now this is 100th away. And try that. And then add in another 0, and another 0, and another 0, until it's really clear of what is all of this getting to that we know we can round to. 5.25. This is just 0, 0, 0. So 5.25 are the important numbers there. We don't want to round to 5.3 because that's not as precise. And you see that they match. And we talked about when a limit from the left and from the right are the same, then this general limit is that same value. It exists. Well, then to find f of 3, I'm just going to clear this out and simply put in 3, and it'll tell us that the y value is -4. So what's happening with this graph is that it's got a smooth continuous curve, but I guess at 3 there's a hole because this y value, that's the actual point, does not exist where the curve is happening. So we'll submit that. And we've got 3 more to try. Okay, so now we're going -5 from the left. Negatives are different in my head, so think -5 to the left is actually -6. You get more negatives. So I want a little more negative than -5. That would be -5.1. And then I'm going to add in zeros. And you can see that it's going to be 4.5 is what the 9s will make the 4 round to. So we're going to say 4.5. Now, -5 from the right-hand side is a little less negative. So that's actually -4.9. Add in some more 9s. And you see that the zeros are just kind of making the rest go away. So it's -0.05. Well, from the left, it's a positive 4.5. From the left, it's a -0.5. They're coming to different y values. So the general limit does not exist. And then we'll type in -5 and see what that gets us, 4.5. So what's happening in this one is from the left, it's coming to a different value from the right. So there's a jump there, but then there is a closed point on this left-hand side. Okay, 2 more. These are actually the level 2s or type 2s. They're not that much different, but we'll try a few. All right, -2 from the left. So that would be a little more negative. That would be -2.1. And then add in some zeros. And that's going to round to just -1. You could keep going if you wanted to, but it's just going to get more and more 9s. Maybe eventually. Yeah, eventually it would say -1. Okay, now -2 from the right would be a little less negative, so that's -1.9. Okay, this is a good case of why can't I just type in -1.99999? you know, and just seeing like, oh, hey, this is it. Well, you're not seeing the pattern. Look at this pattern of we're barely getting smaller with our x values. Our y values start out almost 0, gets up to almost 1. Now it's almost 3. Gets 3. You would think, hey, it's 3. Then it jumps back to a negative. That's this oscillating behavior. Think of an oscillating fan, goes back and forth, goes up and down and up and down and up and down. And it's happening so close together that we can't define a value here. So if you ever see it going from big to small and then back to big, or vice versa, that's going to be a does not exist. And if one of the limits does not exist, then the general limit definitely can't exist. And then we just need to try our -2. And that just is 3. So it's a very weird function. Okay, and last one. -2 from the left. So we got our -2 again. That would be our -2.1. You can see that's just going to be -2. And we want our little less negative, -1.9. And so you can see that's really rounding to a 3. Ooh, see, I almost went, I knew this one was weird. I had to keep going. Because look what happens. It's getting bigger, it's almost 3, and now it jumps back. If you were to continue on, look, it jumps back again. It's doing that weird going up and down and up and down and up and down. So that actually does not exist. So the general limit does not exist. And then if I try in -2, it's actually undefined as well. And so what's happening is we have a curve that comes to -2 for a y value, one that oscillates, and then there's actually not even a point there at all.